So now that you know the genetics and symptoms of cystic fibrosis, I will now explain the simple process of how it works on the molecular level.
Alright, I'm ready.
Cystic fibrosis works when the CFTR gene is affected. With the affected gene, it goes through the process of transcription.
What's transcription?
Transcription is the process of using DNA as a blueprint and rewriting it as mRNA. Once the copy of DNA is made, mRNA, it is made into an actual product by ribosomes through the process of translation. The end product is a protein.
So if the DNA is corrupted, what happens to the protein?
The CFTR protein is a special protein that becomes a channel protein. A channel protein is embedded in the cell's membrane, acting more of a gated entrance to regulate what comes in and out of the cell.
So what is the difference between the normal protein and the corrupted protein?
A normal protein works by transporting chloride ions and water out of the cell, which is used to thin out the mucus. However, with the corrupt protein, it loses its function and structure due to misfolding. The deformed protein cannot do its job, let alone transport the necessary molecules to the thin mucus.
The protein misfolds. How?
When the protein is made the correct way, it can fold into the correct position through different bonds, like hydrogen and peptide bonds. However, when the protein is corrupted, it doesn't have the bonds in the right place, and it cannot bond correctly. Think of it as having buttons on the wrong place on a jacket, so the jacket can't close.
So in summary, cystic fibrosis is when the gene is damaged and the protein comes out deformed?
Correct, and it's still able to form, like the jacket metaphor, but is unable to button up correctly and create the full jacket.
And because it cannot button up correctly, it cannot function at all?
Yes, and the protein cannot transport the chlorine ions or water outside the cell.
Molecules are used to make thick mucus into thin mucus.
The thick mucus builds up, which causes all the symptoms of cystic fibrosis, which was discussed with your other doctor.
I think I understand now.
Now that you know how it works through the molecular level, it's up to you what you do with the information, but I'm glad to help you understand.
Alright, thank you, doctor.